Your graphing linear equations test review. First thing that you need to know for your test is slope of graphs. Remember, slope of graphs are rise over run. So we need to pick two perfect points and determine our slope. On our first graph, we have our perfect points. So we're going to make our triangle. We're going to go up and over, and we rise 1, 2, 3, 4, and we run 1, 2, 3. Rise over run. My slope is 4 over 3, and that's a positive 4 over 3 since my line is increasing. If we look at our second one, we need to find our perfect points. We can use this one and we can use this one. It doesn't matter which two perfect points I choose, as long as you can tell me the exact location of the points. So let's say I decide to use these ones. We have 1, 2, 3, 4, and 1, 2. Remember, rise over run. Our rise was 4, our run was 2, which makes 2. But my line is decreasing, so I need to make that a -2. Alright, next we have slope of tables. Remember, there's two ways we can do this. We can do this with I'm going to do one with one way and one the other way. So we can do our rules down the side. 2 to -2 is subtracting 2, 1, 0, -1, -2 is -4. -2 to -6 is -4, and -6 to -10 is -4. 9 to 3 is subtracting 9, 8, 7, 6, 5, 4, 3, 6. Same thing here, 3, 2, 1, 0, -1, -2, -3. That's -6, and then -6 here. Remember, it's the change in y over the change in x. My change in y was -4. My change in x was -6, which a negative divided by a negative is a positive. And 4 over 6 simplifies to 2/3. The other way we can do this is y2 minus y1 over x2 minus x1. So we can choose any two that we want. Let's say I make this x1, x2, y1, y2. y2 is 3 minus y1 is 9 over x2 is 4 minus x2 is 1. 3 minus 9 is -6. 4 minus 2 is 2, which makes that a slope of -3. Alright, next we need to do the slope of ordered pairs. I'm going to show you the y2 minus the y1, and I'm going to show you how you can put it in a table. So this is x1, y1, x2, y2. So we can do y2 minus y1 over x2 minus x1. My y2 is -6, minus my y1 is 4, over my x2 is -5, minus my x1, which is 3. That makes this -10 over -8, which that simplifies to 10 over 8, which again simplifies to 5 over 4, because remember, the negative divided by a negative is positive. We could also make this a table. X, y, -3, 0, and we have 4, -1. 0 to 1, -1 is subtracting 1, and -3 to 4 is adding 7. So it's the change in y over the change in x, -1 over +7, which that's my slope, -1 over 7. Slope of equations. Remember, slope-intercept form is y equals mx plus b, where m is your slope and b is your y-intercept. And here's some steps for putting an equation into slope-intercept form if it's not. So we have y equals mx plus b. My slope is 6 because it's the number in front of x. Here my slope is -4 because that's the number in front of x. Here we don't have these in slope-intercept form, so I need to put them in slope-intercept form. We always move the number with x first. That leaves me with negative 4y equals 3x, and I'm putting plus 12 because that's a positive 12. Divide everything by negative 4 because that is multiplication, and the inverse of this multiplication is division. So I have y equals negative 3 over 4x minus 12 divided by 4 is 3. And here your slope is negative 3/4, since that's what's in front of x now that it is in slope-intercept form. Next we subtract 6x from both sides because we have to move x first, and this is adding 6 and the inverse is subtracting 6. That leaves me with 3y equals negative 6x. This is positive 24, so we're going to put plus 24. 3y is multiplication, so we divide everything by 3. That's y equals negative 6 divided by 3 is negative 2x. 24 divided by 3 is a positive 8. So my slope is the number in front of x, and that gives me negative 2 as my slope. Next we have y-intercepts of graphs and writing their equation. So remember, a y-intercept is where it crosses the y-axis. So here, my y-intercept is positive 2, since it's where it crosses my y-axis. Now I need to find another perfect point so I can find my slope. This is the same graph from the first page. Our slope is rise over run. And I have 2 over 1, which is 2, but my line is decreasing, so that's going to be negative 2. So we put it in y equals mx plus b form. Remember, your m is your slope, and b is your y-intercept. So when we write the equation, we have y equals negative 2x plus 2. My y-intercept of this equation, this is actually not a perfect y-intercept. So we're just going to say it's negative 1 just for practice purposes. And we're going to rise over run with the points that we've been given. 1, 2, 3, 4 over 1, 2, 3. My slope is rise over run, which is 4 over 3. So my equation is y equals 4 over 3x minus 1. And y-intercepts of tables. Remember, we have to look for where x is 0. Okay, and I actually don't have one at all. So we need x is 0. 0 is between 3 and negative 3. So I'm going to make 3, 2, 1, 0, negative 1, negative 2. I'm going to make my own little table off to the side to kind of help me out. 3 was negative 2, and negative 3 was negative 6. And there's 1, 2, 3, 4, 5 spaces in between. Negative 2, negative 1, or negative 2.5, negative 3, negative 3.5, negative 4. I'm just trying something out. That's not going to work. So negative 2, negative 3, negative 4. This one's a little tricky. Negative 5. We're going to say that our slope is, or my y-intercept is negative 5. My slope, negative 2 to negative 2, is subtracting 4, and 9 to 3 is subtracting 6. Change in y over the change in x. That gives me negative 4 over negative 6, which is 2 over 3. So I have y equals 2/3 x minus 5. Here we need to know the value of x when or the value of y when x is 0. So we have 2, 1, 0. So we just need to work back a little bit. So this is subtracting, this is adding 1 each time. And this is subtracting 3. So we're going to add 3 in the opposite direction. That's 12. That's 15. So my y-intercept is 15. My slope is the change in y over the change in x. The change in y was 3. And the change in x is 1. So my slope is 3. So I have y equals 3x plus 15. Y-intercept of equations is the last number as long as it's in slope-intercept form. So my y-intercept in this one is -4. My y-intercept in this is -6. We need to put these last two in slope-intercept form. Subtract 3x on both sides. That leaves me with -2y equals -3x minus 6. Divide everything by -2. That's y equals +3 over 2x plus 3. So my y-intercept is 3. Here, we add 6x to both sides. That's 3y equals 6x plus 24. Divide everything by 3. That's y equals 6x divided by 3 is 2x. And 24 divided by 3 is 8. And my y-intercept is 8. Last 4, we got to talk about how to graph. We plot our y-intercept first. My y-intercept is -4. My slope is 3. Remember, slope is rise over run, which is 3. And this does not have a denominator. Remember, every whole number has a denominator of 1. So we plot my -4 y-intercept, and we rise 3, which is going up. 1, 2, 3. 1 run. We can do that again if we want to. Rise 3, run +1. Oops, I went up one too many. Make sure you're counting carefully, because you can see I just made an error. Alright, next we have our y-intercept of -6 and our slope of 2 over 3. Remember, it's rise over run. We're going to rise +2 and run +3. So we're going to plot our y-intercept of -6. We're going to rise 2, 1, 2, run 3, 1, 2, 3. Rise 2, run 3. Alright, last two are not in slope-intercept form. We have 3x minus 2y equals -6. Subtract 3x from both sides. -2y equals -3x minus 6. Divide everything by -2, and I have y equals 3 over 2x plus 3. My y-intercept is +3. My slope is 3 over 2. Remember, rise over run, which is going to be 3 over 2. So my y-intercept is +3. I'm going to rise 3, run 2. Rise 3, run 2. Last one, -6x plus 3y equals 24. We're going to add 6x to both sides. That leaves me with 3y equals 6x plus 24. Divide everything by 3, and that's y equals 2x plus 8. My y-intercept is 8. My slope is 2. Remember, rise over run. My rise is 2. The denominator of 2 is 1. So we're going to plot our 8. We're going to rise 2, run 1. But I'm out of room, so we can also make the opposite of 2 is -2. The opposite of +1 is -1. So I can rise -2, which is going down 2. And I can run -1, which is going left 1.